Yeah, short introduction about myself. I am Muhammad, software engineer. I have a background experience in database distributed systems, building highly analytical in-memory database. And recently I joined Ververica, which is a company which originally created Apache Flink. And I also started learning about streaming. And in my spare time, I like playing board games, swimming, and running. So most of the content of my talk today will be based on the book, Streaming Systems, which was written by the Tyler Akidao, Slava Chernak, and Rowan Lux. It's really good if you are learning about streaming systems. The book introduces all the fundamentals you need to learn, such as watermarks, what they mean in streaming systems. And there is a quote from the book. Julian Haidt is fond of saying streams are like derivatives of the tables, and the tables the integrals of the streams. I think it's a nice quote to set the stage for my talk. Julian Haidt is a lead developer of the Apache Calcite project, which powers all the SQL engines in Java ecosystem and Apache projects. And he was also one of the pioneers who lead the Streaming SQL initiative together with the Apache Flink, Apache Apex, and Apache Beam communities. So let's talk about the streams and tables. As I told you, I have a background in a database, so I know rows, columns, and unique keys. And I start learning about the streams. Apparently, there is a duality between the two, so one can be derived from the other or vice versa. And powerful thing is, in database, of course, you always have the SQL interface. And I learned that you can also run the structured queries on top of the streams, which I found very powerful. So, as I mentioned, there is a duality. One can be derived from the other, but how? Let's look. From streams, we can produce table, which is an aggregation of the stream of events over a period of time. And the result of that aggregation is stored as a table. And similarly, we can create a stream from a table. If we observe all the changes which are happening in a table, which apply to the table, all those changes can be seen as a stream. But we should also loop them independently, separate from each other. A table is a resting place for a data to accumulate over some time. And the table represents data which is at rest. Likewise, streams capture the movement of the data within a table as the changes happen to the table. So streams represent data which is in motion. So let's imagine we have a data pipeline like this, where we read from some files in a file system. We apply some map operation on top of it, and we do some grouping using group by or key by, and do some aggregation, here summation, and then we send the result to the next operator, which can write it to some other database or some other system. So in this pipeline, we read the data, we parse the input, and aggregate some values using for each key, and we send the results to the next operator. So this flow can be seen like this. So we read the input, which can be represented as a stream, and we apply the map operation on top of the stream, which also produces a stream. And then we do a grouping operation, which does a summation, which creates a table. And once we receive end of the input indicator, once we process all the files, that grouping operation can send its result as a stream to the next operator. But in this example, we are working with the bounded data. So we have some files in a file system, and we know that there will be the end of the input indicator. What if we have unbounded data? So we are working on streams. And given the grouping operation, like we did with the summation using the key by, what kind of triggers we can use to set the result into a motion? For that, we need to learn two more concepts in streaming systems. One is the windowing. It's a process of slicing data into some temporal boundaries, and here you can see 3 approaches. The first one with a fixed windowing, it's a window with a fixed size. And the second one is a sliding windowing approach with a window size and some interval. Of course, if the interval is less than the window size, you would get the overlapping windows. And the third one is a session windows. It's a window with some gaps in between. And this kind of a windowing technique is useful, for example, if you are doing user behavior analysis, such as a user watching a YouTube videos during the day. And the second concept we should look is the watermarks. Imagine we are doing some operation using a windowing, and we have a window begin and window end. How can we be sure that all the events which belong to that window already processed? And the watermarks helps with that. It's a globally increasing timestamp. It shows some progress of the time in unbounded data in the streaming systems. So whenever we have an operator which receives a watermark with some time t, and if that watermark timestamp is after the window end, that windowing operation can assume with high probability that no more events will come which has a time before the watermark timestamp. So it's some kind of heuristic we can use to decide when to close the window and send the computation we did on that window as a stream into the next operation. So coming back to our data pipeline, we have now unbounded data. Again, we do the reading, parsing, and aggregation. Now we are using the window. Here we can use the watermarks to make sure that once we have a watermark which is past the window end, we can send that result as a stream to the next operator. But of course, as I mentioned, it's some kind of heuristic. You can never be sure that some event will have a late, will arrive late. In that case, for example, in Apache Flink, that late arriving data will be dropped. But if you are using DataStream API, you can be more flexible. You can send it to some other output stream, or just drop it. And if you compare this flow with the previous one, here we sent the table result as a stream in a different times, because the watermark will, for each operation, will arrive in a different time. So on the bottom, you see that we have a 2-minute window, and each of the events which is past watermark events for each window arrive in a different time. Okay, I mentioned that. So let's do a quick summary. We have some operations which are applied on a stream or table, which also yield either a stream or table. And we have non-grouping operations like filter, map, which are applied to the stream. And we can use grouping operations such as group by, key by, to bring the stream of events into a table. And here we can use windowing techniques to add a dimension to the grouping. And similarly, we can use some triggering, like watermarks, to send the result of the table as a stream into the next operators. And of course, we cannot go from the table to the table, because data being at rest cannot go to being at rest without being in a motion first. Okay, let's talk about the streaming SQL, which I found very powerful. Nowadays, any data processing system without a SQL interface is not a complete. So here I will mostly talk about a concept from Apache Flink, which is called the Flink dynamic table. So in Apache Flink, all the changes which apply to the table produce a stream, and this stream is called the changelog stream. And changelog streams can be converted to the table, and in Flink, this conversion is called a dynamic table. And all the operators, like a source, sync, and map operators, work on this changelog stream. And you can also run SQL queries on top of a dynamic table. And in Apache Flink, this is called a continuous query. And continuous queries are never ending. They will update the results dynamically to reflect any change in the input tables. And additionally, changelog streams have some kind of modes. So for example, if you are inserting a new record into a table, that will be represented with +i insert operation. And if you're updating a record, it will produce two events with -u and +u. The first one contains the update before mode, which contains the previous value of the before the update, and the update after contains the new value. And of course, -t for the delete operation. So let's imagine we have a table like this with a name and zip code, and we are adding records to it, updating or deleting. So this table could be seen as a stream. So we have first insert operation. We add John and his zip code. Then we do the update, and it creates two events, update before and update after. And finally, we have a delete operation, which is with a changelog mode, -t. And in Flink SQL, you can create a table on top of the stream. And using connectors, Flink connectors, and each connector has its own implicit changelog mode. For example, we create a table using the file system connector, and this will have a changelog mode with the +i. And if you use Kafka, it will also have the +i only in append only changelog mode. But if we change it to the Kafka upsert, we will have the insert only and also delete mode. Additionally, if you use Kafka connector together with the Debezium format, you will get all the changelog modes. Now let's talk about the CDC. We saw lots of talks today. So CDC is a technique for tracking or capturing changes applied to the database over some time. Debezium is one of the frameworks you can use to apply for this pattern, CDC pattern, but it's not the only one. Today there was a talk, lightning talk from Marta Paes. She also, please rewatch it. You would see many other tools which was introduced in the past, and very exciting companies which are doing the data replication at the moment. And in the CDC, we have a database, and we do some operation on that database, DML operations like insert, update, delete. And with the Debezium, we can track those changes using the transactional log or write ahead log from Postgres, for example, or bin log from MySQL. And all these changes could be sent to the next operator to make your data pipeline in real time. If you remember from the keynote, this is, we don't have to wait for our transactional operational database to be ready to apply some periodic batch operations or bulk operations. Now with the CDC pattern, you can track or react to the real-time changes which are applied to your operational database. So let's do a demo. So for the demo, I have such a setup. I have a Postgres database. I have a Kafka with a Kafka Connect and Debezium connector. And we will add some records. We will create a table in a Postgres. Also, we will apply some operations on that table. And what we want to see is we want to see that each change in the Kafka topic. And later, we will also run, using Apache Flink, some SQL queries on top of those changes and see the results updated in real time. So I hope demo gods are kind to me today. Let's see. So I started the Docker containers. So they should be already running. Is it visible, or I can? Better? Okay, so first thing is I want to, okay, let's go here. So I have all the Docker, Kafka Connect all running, and now I want to update my Kafka Connect with the Debezium connector. So I will run this script. Basically creates a so we create the Kafka Connect, Debezium Connect, which is tracking the changes which are applied in a Postgres database. And similarly, I have not this one. It's called some SQL query which creates some table orders in Postgres. I enable the logical encoding, which is required for the Debezium to track the write ahead log, and I add some records into it and also update some record and delete one. So I will run this Postgres populate. So we did some operation in our database, and now I want to consume. So at the moment, I am expecting the using Kafka Connect already populated the Kafka topic, and I should be able to observe all the changes I applied to the database in my Kafka topic. So I will run such a consumer real quickly. But so as shown in a demo setup, I am expecting Debezium format in the Kafka topic. So I am only at the moment, for the sake of the demo, interested in the operation which was applied. So as you can see, if we go up, so here are some records in a JSON format. So we have the operation type, which is C in a Debezium, which basically means insert operation. And we also have the U here, which is update operation. So in the U case, you can also see that we have the update before and the update after. So basically, I changed the amount from 50 to 20 something. And finally, we also have a delete operation, which removes the record from the above. Okay, so that's fine. And we can also do, let's do some interactive updates to the database. So I will go to the Postgres, and so we can insert a new record. I think it should be name and amount. So yeah, randomly let's insert Dave with 10. So when I run this query on the above, on the Kafka consumer, I'm expecting to see a new create, or operation create, or insert to be seen. So when I add the new record, immediately I can see on the consumer that we have a new record. And we can also update it. Let's set amount. So it was 10 to the 20. Our ID is 31. So at this moment, when I do this operation, I am expecting to see two events with the update before and update after. And on the above, we can see the operation update before, update operation with the payload before and after. So far so good. Let's also run SQL on top of this change event. And for that, I will maybe need this, but yeah, let's do this. Have some SQL statements prepared already. So I will set the color, which was suggested to me by the Sergey, one of the committers in the in the Apache Flink project. I will do some preparation. And now I am going to create a table on top of the Kafka topic. So here I am creating running a SQL statement in Apache Flink, which creates a table using the Kafka connector and the Debezium format and some other required metadata. So now I have an orders table. So what can I do is I can do select star from orders. And here I am expecting to see the records we added in the table. Okay, so the Alice and the Carl was added before, and I added the Dave just now. So let's insert a new record. So now we do, maybe we add Bob with ID 32. And when I run this insert statement on the right side of the screen, I am expecting to see a new table record in Apache Flink. So Bob also inserted into the table. So this is a continuous query which dynamically updates the result when the change happens in a source table. And we can also do the update operation. 32. So for example, let's lower the amount for the Bob to the 5. And we see the Kafka topic also updated the change. Also you cannot see the amount, I think, or can you? Yeah, so the 5, yeah, you can believe me, it was updated, I think. Okay, so, but let's also run some aggregation on this table. So let's do and group by name. So this should also run a continuous query which will update. So if we insert a new record for the Bob, so imagine Bob has another transaction. So now I am expecting the table update the result to the 15 for the Bob when I insert this record. Okay, so it's updated 15, and we can do also delete. So let's just delete the Bob's last record. I think I am doing something wrong. Sorry, thanks. Yeah, so it should go back to 5, yeah. Okay, so that was for the, I want to show one more thing. And let me just copy it here. So, maybe I should have it. So let's quit this. And so we set the result mode to the table, but we can also change it to the Tableau mode. And in this case, we can also see all the changelog modes which are applied to the to the table. So here, if we let's just zoom this. So you should be also seeing the operation mode. So we added Alice, then Bob and Carl, then we updated the Alice's record and deleted, and everything is also seen in this result mode Tableau. Okay, that's for the demo. And I want to talk about the Flink CDC a little bit. So if you don't have Kafka or Kafka Connect set up, you can also use Flink CDC. And with the Flink CDC, you just change the connector type to the MySQL CDC, Postgres CDC, or Mongo CDC, and it will give you all these changelog modes. And with that, you can also use Flink's power to enrich your real-time processing, join, also write the result to the other source. And the Flink CDC was adopted recently to the Apache Flink project. It's very active, very early phases. But tomorrow, I think at 5 p.m. in this room, Leonard Shu, which is one of the PMCs of the Apache Flink project, will go deeper into the Flink CDC topic. So with the Flink CDC, you can get all the changes which apply to many sources and run your data processing pipeline, ETL, do some aggregation, enrichment, decision making, and store the results in a data lake, data lakehouse, any other system. So to conclude, we learned about the stream table duality and how they are transformed from each other. And we learned how streaming SQLs are using this concept to run the continuous queries. And we tied all together by using Debezium for CDC with Apache Kafka and Apache Flink. And some references, of course, the book from the Tyler and co-authors, Streaming Systems. I highly recommend it if you are learning about streaming systems. And presentation from Jark and Timo. They are lead developers of the Flink SQL project. And of course, Gunnar, who also gave a talk today, lead developer of Debezium, has many resources, talks about CDC and stream processing. And Jark and King Sheng has really nice talk about the CDC and the Flink SQL in Flink Forward. And for the demo, I also used the repository from Marta Payas as a reference. And some announcements, and my company, Ververica, also organized Flink Forward. And this year, it will be 10-year anniversary. It will be in Berlin, where the Apache Flink project originated. And in 10 years, it's amazing how the community grows and many things achieved. So feel free to join and celebrate the anniversary. And tomorrow in Expo Hall, Ververica also does small Oktoberfest event. So you can go there and drink a beer or eat, enjoy the food. So you can also join that and talk about the Vera engine we have in Ververica Cloud Native engine for the Flink. Yeah, that's all from my side. Thank you very much. And if you have any questions, I'm happy to answer them.